Right. So my name is Tomasz, and I'm going to talk to you about a super boring topic, which is spreadsheets, like the most boring piece of software you can ever use. But we're going to try to make it well, exciting. Maybe is too much for word, but we're going to try to make it fun. So yeah, my name is Tomasz. This is my mug. I'm the one on the right. I've been a professional developer since 2005. I've never considered myself like a JavaScript developer or JavaScript-oriented developer, just a web developer doing backends or full stack, and JavaScript kind of caught up. When you're being a web developer since 2005, you remember very early days of JavaScript, the joy of discovering, XML HTTP request method that was added to Internet Explorer, then people using it, calling it Ajax. If you remember those, you probably had a pretty cool childhood, but please get yourself tested, like go to a doctor and have like full blood work and stuff. Because for the last 10 years, I was like founder and CEO of a software company, of consultancy called Rebased, and since September we are all at Shopify. We have all joined Shopify. So those titles don't look much of like engineering titles, but believe me, I do write some code, and you're going to see some of it here. So you'll be able to judge by yourselves. So the big risk, or one of the biggest problems or challenges of being a developer, one of the biggest advantages and disadvantages is that we like building stuff, and building stuff comes at a price or comes at a risk. We are great at creating apps to solve problems. The thing is that we sometimes are too eager to actually build apps to solve problems which could be solved in a way smaller, approaches or amounts. And this can sometimes lead to a rabbit hole of spending way too much time on stuff that can be done with completely different tools or a smaller amount of code, up to a point when developing an application will take days when it could have taken a couple of hours. This one is pretty old. I think Webpack and Babel are a bit more friendly to use right now, but this was exactly my experience some time ago as well. So this is going to be a presentation about JavaScript that's not going to involve any Webpack. So I hope that's a good thing. So. This is one of the reasons why you have the no-code and low-code approach, and basically trying to use and trying to promote platforms which allow us to write a bit of code, but not like entire full-fledged applications, not have to worry about deployments, not have to worry about specific things. Sometimes a lot of stuff can be done just by setting up a proper IFTTT pipeline, but sometimes that's not enough. But let's talk about spreadsheets first. So spreadsheets basically do the job for many people and for many professions. One of the biggest challenges of every startup or every SaaS company is they need to be more convenient and more functional than actually Microsoft Excel or Google Sheets or something. Like basically, spreadsheets are a way to at least solve most of the organizational problems, most of the data-related problems, most of the data operations, as long as they're on a smaller scale and as long as they don't involve complex operations. But we don't always have to fight against spreadsheets. And of course, spreadsheets have a lot of positive points about them, lots of pros, especially for non-technical people. And I'm going to use the name sheets instead of spreadsheets because spreadsheet is a mouthful. So I'm going to just say the word sheet, but I mean sheet with double E. So sheets are familiar to most people. Like everybody had encountered sheets, throughout their career. Sheets are familiar to everyone. Sheets are easy to use. They're easy to adapt, or they are, easy to make people get used to them. And also, sheets have this funky way of having the data and interface being one and the same. You see the data in usually a form of a table. Like if you see a spreadsheet but it's not a table, then something went wrong somewhere along the way. And it's exactly your interface. You can click into any specific row or you can click into a specific cell and edit it directly. This makes them pretty useful, and this makes them the best first step for solving a specific problem. So it also means that since they are easy and familiar to non-technical people, this also means that for us technical people, they are boring and not interesting. Whenever we have to use spreadsheets, and believe me, I've been using them, for the last 11 years a lot, because when you run a company, you basically have to run a couple of numbers here and there outside of actual coding jobs. We treat spreadsheets as a punishment. Like nobody wants to have to use them because they are the boring part of running anything. But what if they don't have to? What if we could script them with JavaScript? And of course, this is nothing new. Like everybody going for an advanced course on spreadsheets actually had the chance to get familiar with some sort of like language or tooling to build their own custom functions. And usually, if you had it at school, at university, it was usually a way to write a different mathematical function, a way to differently sum up or combine or correlate numbers. Still boring, right? You still have numbers and still have to do something within those numbers. Your spreadsheet is, in terms of functional programming, if you're at the functional programming talk, your spreadsheet is still like self-contained. It's pretty pure. You have some numbers coming in and you have some numbers coming out. That's it. But what if spreadsheets could talk with external API? And this is going to be an interesting part. This is going to be the interesting part of this presentation. Like 3 slides in and we'll be done. What if we could use our spreadsheet as a way to interface with external API? So not as technical as curl or wget or I don't know, a Postman or Insomnia or whatever you use to interact with a JSON API. So what if it was a bit more friendly, giving us already some sort of front-end, even though it's not going to be as friendly or as custom-made as, of course, like a specific front-end or full-fledged application. So turns out there is such a way in Google Sheets, and this presentation is going to be Google Sheets oriented, but there is an analog of this in Microsoft 365. So even if you are very Microsoft bound, and even if you are only going to use Excel in Office 365, so the online one, you are still going to be able to do a similar thing, even though with a bit of different code, but also with a bit of better tooling. Like actually, we are at this point in history where Microsoft is offering better JavaScript tooling for their own products than Google does. So there are custom functions in Google Sheets, and those custom functions include some classes or methods that allow us to fetch an external URL, which is pretty awesome. And also, so the moment we begin having like a JavaScript runtime environment in our spreadsheets, and we are able to send external requests, that's basically it. Like I said, we are getting really close to to the final stages of this presentation. So let's get to the action, but I'm not going to do live coding. I hold the microphone in my hand, and I had a discussion about it during yesterday evening with Amit, hi, that doing live coding on a conference is a recipe for disaster. So I'm just going to show some listings of code. I'm just going to show you recordings of how it works, but also I can provide you with the link to the actual spreadsheet where it actually happens, where it's been actually recorded, or I can like open it. I think I even have it open, and then you'll be able to see it, but I'm not going to write code on this presentation unless we have a bit of more time at the end. So this is an example of how it's going to work. We just type in a function, a custom function, and that's it. And it's going to fetch data from external source, and it's going to show this data in a tabular manner. How does it happen? Yeah, so that basically concludes the interesting part. If you're going to go out, I won't feel sorry. But if you want to stay for a couple more slides to see how it actually happens and what are the perspectives and possibilities, and also when you shouldn't use it, then please enjoy. So, how do we do it? We generate a very simple API with mock API. If you don't know mock API, it's basically a service where you create a mock API, more or less. You get your custom URL. You define your collections and with a specific structure or specific data, so we're going to get some fields and some values and a couple of HTTP methods. So you're going to have the method for getting all of them or getting a paginated collection, a method for getting a specific one, but also invasive methods, so like post, put, patch, delete, and so on and so on. So we generate such a mock API. It's very simple. The moment we generate it, the moment we name it, we basically get our custom API endpoint, and we just define collections, resources, and stuff. And then we write a bit of code, and it's really, really small amount. Basically, and this is our entire code for the spreadsheet scripting. we have the base URL where we have the URL that we just got from mock API. Then there's a very unorthodox in terms of JavaScript way of fetching this URL, because as you can see, we do have synchronous I/O. So this is a bit different than our usual JavaScript experience. Like in line 5, we have a guarantee that the line 4 has fired up and completed, and we have its response available. And line 6, we are sure that we have all the response JSON loaded from line 5. So no asynchronous I/O, no callbacks, no promises. Like you can basically treat JavaScript as a very simple I/O language with a blocking I/O. And this works also because it's probably run on Google servers. It's not going to be run in your browser. So this is a bit different than your regular JavaScript. But basically what happens, we get this JSON, and we can actually visit this URL. We can see what this JSON looks like. But let me tell you, it's very simple. It's an array containing a bunch of hashes, bunch of objects with the keys like ID created at name. What we just need to do is we need to map it into an array of arrays, because this is what spreadsheet operates on. Spreadsheet operates on a rectangular array, which is, in terms of programming, it's an array of arrays. So that's it. So we just map this data, and then it ends up in our spreadsheet in a structured way. This is again the same video. So we just fire this function, and if we have working internet, I'm going to be able to also show it in reality. Also, if we change this data in the mock API backend. But this is, of course, mock API. This is very simple. Real APIs are usually a bit more complex. Real APIs usually have filtering. They have authentication. So we need to usually create some sort of header for our request. We need to create some parameters. So this, of course, incurs a bit more complexity. But then again, this is the only extra complexity. So, for example, if you use toggle for time tracking, it's kind of blurry, but you should probably see that there are, like, let's say, 5 time entries in toggle. And yes, this is exactly the genesis of of this talk, of why I've started doing JavaScript in spreadsheets. Because when you work with timesheets, yet another sort of shit, then at some point you begin having to pull this data into a spreadsheet to just operate, see, how much was worked on a specific project, what are the budgeting, like limitations, what's going on with the, if the project is totally going south, or is it only going south by a predictable 30%. And this is basically the genesis of how I stumbled upon spreadsheets and scripting them, which is kind of weird because people usually stumble upon this stuff by accident, just as me. Because actually, the ability to script Google Sheets has been there since 2009. Basically, this was a pet project of some Googler, which turned into a fully functional programming, basically, environment, and most people don't know about it. But thanks to that, you can always give a conference talk about it, right? So nothing's lost. And this is basically how it's going to work. Like, we had those 5 entries, but what's going to happen is we're going to get actually only 3 entries back. Why? Because there's going to be some summation happening. So we are going to get only the so-called summaries. So only how much time in total has been spent on a specific project, right? So we had 5 entries, but 3 of those were on the same project, the new zombie virus. Yeah. So this presentation, so this slide and this image is from 2018, when it was actually funny to joke about a virus taking over the whole world. I'm also really happy to finally have a conference in person, So anyway, because we're getting summary, which is like one of the modes of Toggle API. So this time we're actually going to work with an actual API. And also, by the way, in the code listing, you're going to see actual URLs and actual keys and actual authentication passwords. And they still work. You can use them, so you can totally break my toggle. But don't worry, it's a throwaway account that I just used for mock data. So you're not going to incur any real damage. But if you want to go ahead, we can always see how it's going to work later. And that's the only difference between what we did with mock API and an actual API. Now, there's a bit more, setting up parameters, for so-called grouping, subgrouping, rounding on or off. Then filtering, so like since and until. Some of those we're actually accepting as parameters to our function, which is pretty cool, as you saw also on the demo. And of course, we need to give a authorization header, which is, as the name implies, it's authentication, not authorization, but HTTP is funny. And the rest of the entire function is this. Like, again, we have the same 3 lines at the top. So, we just fetch the URL, we just parse it as JSON, and then we just need to message the data a bit and map it into an array of arrays, and that's it. The question that might arise, and this is a dangerous question. This is a question that shouldn't leave this room. Like at this point, we should treat it like Vegas. Let's talk about it, but don't use it outside of this room. Can I post data from a spreadsheet? Can I use my spreadsheet to create data that will then fire up an invasive action onto my backend? Of course we can, but please don't. The very nature of spreadsheets and how those functions are fired up. When you are writing this function, but in Google Sheets you don't have control over when it's fired up or when it's fired up again. So what might happen is that you might have a function that you wanted to call once, but that has been called 3 or 4 times with the same data. So you can have it running, but please use it only when you're really sure that the endpoint is idempotent, so that it's not going to produce different results if you fire up the same function of the same parameter, same data 2 or 3 times. So maybe don't use it to create new records, because then it's going to probably pollute your database, unless you set up the ID on your own. Maybe use it only for updating or something like this. And other than that, it's exactly the same. The only difference is that in line 23, we need to support payload to our API, which is the data that we have just fetched from the spreadsheet. And there are 2 different ways to do it. We can either, hard code which range in the spreadsheet is going to be taken into account, or we can try to pass the numbers of cells and rows and columns. So basically, the range of data that's going to be used into the actual function. But yeah, this was actually also working code, even though it's not going to work now because I don't have this service running behind this ngrok endpoint. So it's also time to ask a question. Is this Google script? So I kind of brushed off this posting data because please don't, in my opinion. You shouldn't probably do it. If you really have to, you totally can, and we might even get to a scenario after, in the end of the talk, discussing when it might be practical or at least funny. But still, again, there's this elephant in the room of if this is actually JavaScript. Well, in the official documentation, Google calls it JavaScript, but sometimes Google calls it Google script. I think that's a huge wasted opportunity to call it sheet script. So it is a JavaScript. It's also a pretty funky version of JavaScript. It's based on ECMAScript 4, which is again this pretty old version that still didn't have a lot of, didn't have lambdas or anything or arrow functions. But there are a couple of features from ECMAScript 5, which is I think 2015, right? There are a couple of features from ECMAScript 5, but not all. So unfortunately, you have to write those functions carefully and see which calls are supported, which calls are not. And there's of course the huge thing about this, all those functions, all those APIs having synchronous I/O, which is kind of weird. One of the parts that are also pretty uncool about it is that you do have vendor lock-in. And is this the slide? Yeah. There is vendor lock-in and there's no testing environment. So you write it, it works or not. You have no automated way of ensuring that it's going to work in the future. At the moment it stops working because Google decided to deprecate it with a 2 days notice, because that's what they do. It's basically your problem. So it's probably not a good idea to use it for some very mission critical stuff. But then again, who's using spreadsheets for mission critical stuff, right? Everyone, that's right. But I mean, has Google ever deprecated the service, right? But if you're using actually Office 365 with their own flavor of this spreadsheet scripting engine, actually Microsoft has a full command line environment based on Node.js where we actually define those extensions, and there is an opportunity to actually write at least some unit tests for the methods that you write there. So the drawback is kind of, maybe Google will catch up finally at some point. Of course, you can do way more with it. This has started as a pet project of some Googler back in 2009, and pet projects by Googler are either retired or grown into something very big and then retired. So this means that those APIs that you have available in the spreadsheets actually also have APIs or have methods and classes for accessing other Google services. So for example, you can fetch data from Gmail, you can fetch data from Gmail, you can fetch your data from contacts. Of course, it's going to turn your script into like an entire extension that's going to be authorized to use your, for example, someone's Gmail account, but it's there and it works. You can connect to any database using JDBC. So it's called the Java Database Connectivity Engine. It's again super old. If you remember JDBC, again, please see your doctor. And also, I would suggest not connecting straight to a database from a spreadsheet, because again, it's not exactly the mechanism, with any sort of controls in place and so on. Or even if you do, please only use the non-invasive functions. Please only use it for reading, not maybe for writing to your database. Otherwise, you will be in a world of hurt. And also, you can script generating charts, which is a pretty big thing. Like basically, like charts are the only cool thing about spreadsheets that you can do. So if you can do it even in a programmatic way, it's going to give you even more internet points. So that would be all, and thank you. Unless we have 5 more minutes.
Congratulations, Tomasz.
Do we have 5 more minutes?
Yeah, we have.
I have a couple more slides, actually. So those slides are super fresh, like they are hot off the press. Basically, yesterday at the dinner, I'm not sure if it was you, Amit, or someone else. Someone suggested, okay, so this stuff actually allows us to use spreadsheets as the front end for our data. But what if we try to use spreadsheets as well for the back end of our data, for our data storage? So can you keep data in another spreadsheet and fetch it with an API? So maybe like using Shih Tzu in between. Also Shih Tzu, awesome name. You know this joke that a man went to a zoo, but there was only one animal, a dog. So it was a Shih Tzu. So let's try to look at this, at how it's going to look. For example, I have a spreadsheet prepared with a data source, and it's going to be like super easy. I just typed in some username, some repo name. The first row is always going to be, I can also add something, blah, 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 blah. It's not going to be validated against GitHub or anything, right? So this is going to be my data source. And when I go to the spreadsheet, so when I write this a very simple code, because Shih Tzu actually makes it super easy because you get a very public URL that gets no authentication headers actually. So again, we have all those lines that we saw before. We have base URL, we only have fetching and parsing it as JSON, and then mapping to an array of arrays. And if we run it, we call it fetch it, because I didn't want to spoil the name with Shih Tzu. So if we do it equals fetch it, we'll see if we're ety. No, it's not going to fail. And launch enter, and yes, that's why I don't do live coding. Yeah, and that's it.